Hello friends. Now in this presentation, I would like to discuss a famous and interesting topic, that is distillation, a mass transfer operation. Before starting the actual discussion, I would like to show you the daily life product which we are using in day-to-day life, that is liquefiable petroleum gas, or it is also called as LPG or bottled gas. Then we are also using the petrol for vehicles. Then some of the chemicals, that may be a solvent, that may be a alcohol based products, etc. Then jet fuel, paraffin for lighting and heating for jet aeroplanes. Then diesel fuels for the vehicles which are based on the diesel engines, the lubricating oils, waxes, polish, etc. So especially when we are talking about the winter seasons, we are using these different petroleum products. Then fuels for ships, factories and central heating. And this one, that is called as coal tar or bitumen or asphalt for making roads and roofing. So these are the famous and daily life products which we are using in our day-to-day life. But generally, we are not knowing how to manufacture these types of products. And that is why I'm going to show you this picture and its products. So this is a distillation column, and the products of this distillation column are the gases, liquids and solid products. So the gases may be the refinery gas at 20 degrees Celsius, petrol at 70 degrees Celsius, naphtha at 120 degrees Celsius, kerosene at 170 degrees Celsius, diesel at 270 degrees Celsius, lubricating oils, fuel oil and bitumen at 340 degrees Celsius. So from this picture, we can understand that there are different or variety of products can be manufactured in a single column, that is called as distillation column, but at various temperatures. So from this picture, we also clearly understand that this requires a thermal energy, right? So with the help of thermal energy, with the help of some heating media, we can produce these types of products, and the raw material is crude oil. So from the crude oil, we can convert this crude oil with the help of thermal energy and with the help of this distillation column at various temperatures. These products can be manufactured. So if you understand what exactly the products are, some of the products from the distillation column and what exactly the daily products are, now we will discuss what exactly the distillation process is. So this is one of the distillation technique. It is also called as fractionation. But before starting the different types of distillation and before discussing this technique, I would like to tell you that what exactly the distillation concept is. So distillation is a process in which a liquid or vapor mixture of two or more substances is separated into its component fractions of desired purity by the application and removal of heat. So in this distillation, we are going to separate the two components or multi-component mixture, that may be a liquid mixture or the vapor mixture, and we are going to separate out these components on the basis of heat. So we are going to supply the heat, we are going to remove the heat, and on the basis of some of the factors, we are going to separate these components. So from this definition, we can clearly understand that distillation is a separation technique. So distillation is a separation technique. So it is a separation of liquid-liquid component mixture or liquid vapor mixture, and with the help of thermal energy. So distillation is done on the basis of differences in their volatilities. So volatility or relative volatility is the main terminology which is used in this distillation principle. So we understand what exactly the volatile substance means. So the substance which can easily evaporate or volatile in the atmosphere. If A substance is more volatile than the B substance, then we can say that A substance is more volatile than the B, or we can also understand the concept of this volatility and relative volatility. So this volatility can be defined as ratio of partial pressure to the mole fraction of a respective substance. Suppose the substance A is involved in this feed of the distillation column, then the volatility of A is equal to the partial pressure to the mole fraction. And when we are talking about the relative volatility, then relative terminology is involved. It means it is compared with the other substance. So suppose if only two substances are involved in the feed, then we can say that the relative volatility as the ratio of volatility of A to the volatility of B. And this volatility of A can be defined in terms of PA upon XA ratio. In a similar way, this VB can be defined as PB upon XP, right? So if you are talking about the distillation in simple terminologies, then it is based on the boiling point. It means the distillation can also be defined as it is a separation process, depends on the boiling points of respective substances. So basically, if you are considering the examples of industries or the refineries, then the component is always multi-component mixture. But when we are talking about this distillation terminologies or the concept of distillation in the theories or in the diploma and degree syllabus, then initially we always consider or assume the feed as a binary feed. Binary means there are only two components in this feed, and then we will discuss about this process. So that is the main difference. Theoretically, when we are talking or understanding this concept of distillation, then normally we will consider the feed as a two component mixture only, and then our target will be the separation of A and B. But in the industries, in the refineries, that is not the case. The case is always a multi-component mixture, and we have to separate all these components from this mixture. So this is about a definition and a basic concept of this distillation. The principle of this distillation is, it is a separation of components from a liquid mixture via distillation. Depends on the difference in boiling points of the individual components, and also depends on the vapor pressure characteristics. So it is a process which is a separation process, and it is the component separation process basically on the basis of boiling point as well as on the basis of vapor pressure characteristics or the volatility of the substances. Now, there are different types of distillations. That may be a simple distillation, that may be a fractionation, that may be a steam distillation, or some other distillation types. So if you consider a fractionation, which is a famous distillation technique in the refineries, then you can consider this diagram. So from this diagram, we can understand there are mainly three components in this distillation process, that is called as fractionation. So the components are, this is a distillation column, then a condenser, then reboiler. So these are the main three parts of this distillation column which is involved in the fractionation technique. Then a reflux drum is also involved in this technique. Now we will discuss about how exactly this separation is occur, or what exactly the distillation is. So this is the feed. So feed means the multi-component mixture, or when we are talking in the theories, it is a binary component mixture. So here it is a mixture of two components, say for example A plus B, or benzene plus toluene, or methanol plus water, etc. So our target is to separate these components. So separation of A and B, right? So suppose when we are talking about the benzene and toluene, then benzene is having a boiling point, that is 80 degrees Celsius, and a toluene is having the boiling point 110 degrees Celsius. So obviously you can understand the less boiling point, that is of benzene, which is a more volatile component. So the volatility of that substance, that is of benzene, is more than the toluene. So at lowest temperature, that is near about 80 degrees Celsius temperature, the benzene is going to evaporate. And after reaching near about 110 degrees Celsius only, the toluene can be evaporated. But our target is to separate this benzene and toluene, or to separate this A and B. And for that purpose, to reach this boiling point, to reach that temperature, we have to provide the heat. That is, we must needed the thermal energy. And that is why this component, that is reboiler is added in this fractionation system. So reboiler is a system that is nothing but a boiler system which is going to provide a thermal energy to the feed, and after getting the appropriate or required thermal energy and after reaching the boiling point of that benzene, which is a more volatile component, the vapors are generated and these vapors are sent to the column. So all these vapors or vapor particles of this benzene, mostly benzene and lesser in toluene, are going towards the condenser, where these benzene vapors or benzene rich vapors are going to condense. It means the vapors are going to convert into liquid phase with the help of phase change techniques. That is, the latent heat is going to remove or absorb by the condensing liquids. So the latent heat which is carried out by these benzene rich vapors are removed, and these vapors are going to convert into liquid at same temperature and pressure conditions. It means in this condenser the temperature and pressure conditions are same, only phase change takes place, that is from vapor to liquid. So same concentration, same temperature and same pressure liquid is going towards this reflux drum, where we can decide on the basis of purity, on the basis of our requirement, that whether these liquid particles, or it is also called as distillate, so whether this distillate can be used as a product depending on the requirement, so that we can open this wall as a top product and we can pack these liquid particles in the barrels or drums. If the required purity is not reached in the first cycle, then we can send these liquid particles again to the distillation column, and this liquid particle which is coming from this reflux drum and going towards the distillation column from the top plate, then it is called as reflux. So that is depending on our requirement whether to provide the reflux or not. So this is a simple distillation technique with the help of fractionating column, and this fractionating column involves two parts or two sections. So these two sections are rectifying section and stripping section. So this is the rectifying section and this is stripping section. So the section which is above the feed plate, is called as rectifying section, and the section which is below the feed plate is called as stripping section. So rectifying means we are going to correct these fractions. We are going to increase the purity of these vapor particles. That is nothing but the rectification, and that is why this section where the purity of the vapor particles or the liquid particles is going to increase, they are going to rectify these components in more volatile component. That is why this section is called as rectifying section, right? And the section where these B particles, that is less volatile components, are separated out and which called it as a bottom product. So less volatile components are separated from the more volatile components in the section which is below the feed is called as stripping section. So stripping is nothing but the removal of that particles from that mixture. So here removal of the less volatile component from the more volatile component, and this section is called as stripping section. So the product which is more rich in less volatile component is called as bottom product, and the product or the distillate which is more rich in more volatile component is called as top product. So say for example, if we are considering the example of benzene and toluene, then the benzene is more volatile component. So benzene rich layer is nothing but top product, and toluene rich layer is the bottom product. So in this way, we have separated this benzene from the toluene. So it is nothing but a liquid component separation process with the help of thermal energy, with the help of boiling point, and with the help of vapor characteristics or volatilities or the relative volatilities. So this is the first session. That is why I have explained a distillation in a simple way, and we will discuss the different distillation techniques and different principles of these distillations in other videos. So we may discuss the distillation that may be a steam distillation, that may be a flash distillation, that may be a molecular distillation, that may be a destructive distillation, dry distillation, extractive distillation, and freeze distillation. But basically, when we are talking about the diploma and degree syllabus, mainly the distillation types are simple distillation, fractionation, what we have discussed now, vacuum distillation, and azeotropic distillation.